You are given exactly 60 seconds to answer this question. If you're done with your answers, you can skip the timer and proceed to the discussion portion to verify whether your answers are correct or not. If you may, you can share your answers as a comment in the comment section below. If you need more time, you can pause this video in any moment you want. Your 60 seconds starts now. Here comes a question that combines the idea of coordinates at the same time trigonometric functions. We are trying to solve here the 6 trigonometric functions of 3 pi fourths. To start with, let's consider this unit circle. Let's locate first our 3 pi over fourths on this unit circle so that we would know later the correct coordinates, because before we solve for the trigonometric functions, we need to understand the correct coordinates of this given arc, or the terminal point of this arc. We take note that we can still remember that pi over 4, the coordinate of pi over 4 rather, the coordinate of pi over 4 is actually square root of 2 over 2 and square root of 2 over 2. But we will not be using this because what we would like here is the coordinate of 3 pi over 4. What we just know is that since they have the same divisor, we will just have the same figure, square root of 2 over 2 and square root of 2 over 2. But this is not yet final because we need to make sure that the signs are correct. Going back here, as we know that from here 0 to here, this is pi. Let's locate first the terminal point of the 3 pi fourths. This is pi. If we're going to divide this into 4 portions, so you have 1, 2, 3, 4. 3 pi fourths is here. 1, 2, 3. This is the terminal point of 3 pi fourths. This is the arc represented by 3 pi fourths. Okay, let me do it better like that. Okay, now we know that 3 pi fourths can be found on the second quadrant. What happens to the sign now is that our x would be negative, our y is still positive. That's the difference between the two. Take note of that. You have a separate video for that. You might want to review that in your own free time. Now that we are sure of these points or coordinates, let us now solve for the 6 trigonometric functions. Let's start with cosine, let's say theta. I know, we have an angle here, by the way. Cosine 3 pi fourths, sorry. This is already the arc. Cosine 3 pi over 4 is actually the x value of your point or terminal point. This would mean this is negative square root of 2 over 2. No need to give a value in decimal notation or with decimal notation since this is a non-terminating value, this is an irrational number, so we'll just be approximating, right? This is already the most acceptable result. Next is for sine of 3 pi over 4. If cosine is the x, our sine is the y. So we have here positive square root of 2 over 2. So we are done with the first two trigonometric functions, which are very easy once you have your coordinates. Let's proceed to the next one. It's the tangent of 3 pi over 4. Take note that tangent is the ratio of sine, okay, that's sine, 3 pi fourths, and cosine, 3 pi fourths. So you're just going to take the ratio. Tangent is sine over cosine. Our sine is actually positive square root of 2 over 2, and our cosine is negative square root of 2 over 2. I do hope that my spaces here are enough for the rest, because once you have here, you have what do you call this one? A ratio of rational expressions. Okay, you're dividing rational expressions. If you're going to do that, take note of the steps. Keep change flip method. You keep the first or the numerator. You keep that. You change the operation to multiplication, and then you flip your denominator. 2 over 2 square root of 2. But of course, you can just simply cancel this because we have the same. But let's practice this because this might not be true. The cancellation here might not be true for the rest. Just to for us to have a glimpse of the process. Take note that this is, by the way, negative. Negative. So we have here 2 negative square root of 2, by the way. Okay? So we're going to cancel that. We're going to cancel this. You have negative here. So tangent 3 pi over 4 is negative 1. Okay? Once you're done with this 3, you don't actually need to solve for, you're still solving, but you don't actually need to really express the rest in terms of complicated items. Like, say for example, cotangent 3 pi over 4 is supposedly equal to the ratio of cosine 3 pi over 4 over sine pi over 4, right? That's its structure. So some of us might still go ahead with this, but you can simply look into the relationship of cotangent being the reciprocal of tangent. Now that's easier because you're just going to reciprocate your result. Since your tangent is already negative, instead of this, okay, you're just going to have 1 over negative 1, which will result to negative 1. Of course, if you're going to continue this, I'm going to leave this for you to try. You will still get negative 1 later. Okay, so it's very easy to remember as well the reciprocals, because the next would be the next 3 after cosine, sine, and tangent, like cotangent, secant, and cosecant. They're all reciprocals, like this. The secant theta, or not theta, we have the angle. Secant 3 pi fourths is the reciprocal of cosine. Cosine 3 pi, that's pi over 4. So you have here 1 over, you will have the square root, negative square root of 2 over 2. This would mean, oh my god, I guess I don't have much space, but I have to try the rest. So this is 1 over 1. You can write it like that. So keep change flip method again. Keep change, and then you flip this. 2 over negative square root of 2, right? So that's simply 2 over negative, that's negative square root of 2. But we are still going to come up with the rationalization. So square root of 2, you have here square root of 2, that's 2 square root of 2 over negative 2 here, because that's square root of 2 times square root of 2 is square root of 4. That square root of 4 is 2. You will have a negative sign, and you can cancel this. This would mean secant, okay, the value of secant is negative square root of 2. This is the value of the second. I don't have much space for cosecant, so I'm gonna use portion here. Okay, cosecant 3 pi over 4 is equal to the reciprocal of 1 over sine 3 pi over 4. So it's actually 1 over square root of 2 over 2. Similar to this, you're going to use a keep change method, but what only is different is that you would have negative sign. So this is actually just positive square root of 2, as you're going to reciprocate that just like this here, reciprocate and rationalize later. Pardon if I don't have much space, but this is how we solve for the trigonometric functions of 3 pi over 4. Just make sure that you have your correct point, terminal point rather, together with the sine. And first solve for cosine, sine before tangent. And then just simply reciprocate tangent for cotangent, reciprocate cosine for secant, reciprocate sine for cosecant here. That is how we show the 6 trigonometric functions for a given terminal point of an arc. Thank you for watching.